Homework 1. Graph the linear equation y equals 3/2 x. Let x equal -6, -4, -2, 0, 2, 4, and 6. Find the following y values, then choose the correct graph of the equation. So you can see right here there's a xy chart, and given is all of the x values, -6, -4, -2, 0, 2, 4, and 6, which are the values that are given initially. So they already made that graph for you. Right here, we're going to be looking for the y values. And once we're done with that, then we have to choose which graph represents all of these graphed ordered pairs. So step 1, plug in each x value into the equation for the variable x. So we need to take the equation, which is y equals 3/2 x, and we need to substitute. Let's start with our first x value, -6, so y equals 3/2 times -6. You're going to get y equals -18 over 2. If we simplify that, 2 is a multiple of 8, 2 goes into itself 1, 2 goes into -18 9 times, so you end up with y equals -9. And then it's kind of included with step 2. Then we have to put the answers for each of these plugged in values under the y column of the x chart, which is just right here under the y column. So we can start by putting -9 under the y column right here. And next we have to go to our next. Now let's go ahead and plug in our next x value. We have our next x value is -4. So we have y equals 3 over 2, and then -4. 3/2 times -4 is -12. 3 times -4, -12 over 2. And then 2 goes into itself 1, 2 goes into -12 6 times. Y equals -6. And then we go ahead and plot -6 into our y chart. Go to the next x value to plug in, which is -2. So y equals 3/2 times -2. 3 times -2 is -6 over 2. 2 goes into itself once. 2 goes into -6 3 times. Y equals -3. Let's plug in the 0. Y equals 3/2 times 0. Any number times 0 is going to end up being 0. So we have 0, 0, which, as we know, is the origin. Next, let's plug in 2. Y equals 3/2 times 2. So 3 times 2 is just 6 over 2. 2 goes into itself once. 2 goes into 6 3 times. So y equals a +3. Now let's plug in +4. Y equals 3/2 times a +4, which is the same as 4 over 1. You have y equals 3 times 4 is 12. 2 times 1 is 2. 2 goes into itself once. 2 goes into 12 6 times. So y equals a +6. Plug that into our y chart, or into our y column. Last term to plug in is 6. Y equals 3/2. 3/2 times 6. Y equals 3 times 6 is 18. over 2. 2 goes into itself once. 2 goes into 18 9 times. Y equals positive 9. Plug that into our y column of the xy chart. And as you can see, you have the origin here and negative 2, negative 3. These are the inverse of positive 2, positive 3. So you kind of have an opposite effect going on. So we did step 1. Actually, we did step 2, which is we put the answers for each of the 7 plugged in x values under the y column of the xy chart, which is all of these answers right here. And the last step, step 3, is to just go ahead and plot the 7 ordered pairs onto a graph. Just put in each ordered pair and see which line graph matches the graph of the equation shown. So all of these numbers right here are x and y values. They make up ordered pairs. So the first x value, negative 6, is just an ordered pair, and then y is another ordered pair. So we have negative 6 9, we have negative 4 negative 6, we have negative 2 negative 3, we have 0 and 0, the origin, we have positive 2 positive 3, we have positive 4 positive 6, and we have positive 6 and positive 9. So what we're supposed to do is to put each of these ordered pairs into a graph and then see which line corresponds. So we could actually make a sort of quick ad hoc graph here. And let's actually use a different color to graph these points. So let's start with negative 6 and negative 9. 1, 2, 3, 4, 5, negative 6. And down 9 would be about here. And then negative 4, 1, 2, 3, 4. And then negative 6, 1, 2, 3, 4, 5, 6. Negative 6. So that's negative 4, negative 6. And then just graph negative 2, negative 3. It's going to be negative 2, 1, 2, negative 3. Then we have the origin, which is just your middle point here in your Cartesian plane. And then the fifth point is positive 2, positive 3. So 1, 2. Positive 1, 2, 3. Then you have positive 4 and positive 6. So start to the right 4. And then up 6. 1, 2, 3, 4, 5, 6. Right about here. And then the last point is positive 6, positive 9. So 1, 2, 3, 4, 5, positive 6. All the way up to right about the top. And went ahead and graphed the line. Drew the line. It's a little bit off down in the bottom, but it is, if you drew it, it would end up being a straight line. And then you just have to go ahead and pick which one of these lines up top closest represents the line drawn. And in this case, you can clearly see that this line right here is the line for the solution that we just graphed. Number 5, solve and check the linear equation. 4 parentheses x minus 2 plus 13 equals 3 in parentheses x plus 3. So a linear equation, as we know, is the equation of a line. And a linear equation has x variables that are only to the first power, whereas x to the second power is a quadratic equation. Again, x to the first power is a linear equation, which is a line, and then a quadratic equation, the variable x to squared, normally results in a parabola. Now, it's not necessary to know that to solve this problem, but just a good thing to keep in mind. Okay, so step 1, perform order of operations and solve for x. So pretty much PEMDAS. Let's start with the P for PEMDAS, parentheses. Let's go ahead and distribute these guys. So you have 4 times x, which is 4x. 4 times negative 2 is negative 8 plus plus 13 equals 3. Distribute 3 in the x. Distribute 3 and 3. So you have 3 times x, which is 3x, plus 3 times 3, which is positive 9. And now we just have to keep solving for x. So for x, there's no other like terms on the left side, but you have negative 8 plus 13, which are numbers without variables, so we can add those together. We can simplify that. So negative 8 plus 13 is simply positive 5 equals 3x plus 9. And okay, so again, we're still trying to get x by itself. We can take 3x, subtract it from the right side. If we subtract it from the right side, we have to subtract it from the left side. 4x minus 3x is 1x, or we could just write it as x. Plus 5 equals 3x minus 3x is just, it's 0, it's nothing. And then plus 9. And right here, we're still trying to get x by itself. So to get x by itself, we can subtract 5 from both sides. And then 9 minus 5 equals 4. X equals 4. And the last step, we have to make sure to put the solution, in this case the solution, in set builder notation. So set builder notation is just using these braces right here. These are called braces or curly brackets. A regular bracket would look like this. This is just a regular bracket, just a bracket. Whereas set builder notation, which is this right here, uses curly brackets or braces. So 4 inside the curly brackets is your answer. And the way that they write it is just the solution set. It's a little messy. The solution set is inside the brackets, the curly brackets. The solution set is 4. Also, there's one more step. You need to check your answer. So you need to take the x value that we got of 4, and you need to plug it into the original equation and make sure that both sides of this statement are true. So I put 4 in place of the x right here and also right over here. So these were the x values right here that I plugged in. So you just have 4 minus 2 is just 2, plus 13 equals 3. You have 4 plus 3, which is 7. 4 times 2 is 8 plus 13 equals 3 times 7 is 21. 8 plus 3, 21 equals 21. and that way we know our solution 4 is good. 6. Solve and check the linear equation. 2 times x minus 3 in parentheses minus 3 times x minus 2 in parentheses equals x plus 2 minus x minus 2 in parentheses. So step 1 is to just perform the order of operations and solve for x. So we're solving for x in this equation. So let's just start by using our order operations, which tells us to take care of the parentheses first. So we're going to be distributing each of these different groups in parentheses. So 2 times x is 2x. 2 times negative 3 is negative 6. And then negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6 equals x plus 2. And for step 2, I made a special note because we need to distribute the negative sign with negative x minus 2. So we need to distribute these. So right here, we need to distribute the negative sign to both of the terms inside the parentheses. So negative times a positive x is negative x, and then a negative times a negative 2 is positive 2. Now we just need to continue to simplify and solving for x. So 2x minus 6 minus 3x plus 6 equals x plus 2 minus x plus 2. Again, I didn't really need to rewrite that, but let's actually group together like terms. So 2x minus 3x and negative 6 plus 6 equals, again, group like terms, x minus x plus 2 plus 2. So we have 2x minus 3x, which is negative x. Negative 6 plus positive 6 is just 0. And that equals x minus x, which cancels it out. And then 2 plus 2 equals 4. Now we don't want to have a negative x as our solution. So to get rid of the negative x, we actually want to also realize that negative x is the same as negative 1x. So to get rid of the negative, we simply subtract, or we divide both sides by negative. Negative times negative results in a positive, and then 4 divided by negative 1, so x equals negative 4 over 1, which is just the same as x equals a negative 4. And we need to put our step 3, we need to put our answer in set builder notation. So there we go, set builder notation for negative 4. And finally, step 4, we need to check that negative 4 is the correct answer. So if we take our original equation, 2x minus 3 minus 3x minus 2 equals x plus 2 minus x minus 2, we're going to plug in our negative 4 value for all of our x values in the original equation. So it's 2 negative 4 minus 3 minus 3 negative 3 negative 4 minus 2 equals x plus 2 minus negative 4 minus 2. And we just go ahead and use order operations to simplify. So start with the parentheses. 2 negative 4 minus 3 is negative 7. Stay with the parentheses. Negative 4 minus 2 is negative 6 equals x plus 2 minus, let's stick in the parentheses, negative 6. 2 times negative 7 is negative 14. Negative 3 times negative 6 is positive 18 equals x plus 2. Negative 6 times a negative is a positive 6. Then we have negative 14 plus positive 18 is positive 4. Oh, and actually real quick, I noticed a mistake. Right here, I should have plugged in the negative 4, so plug in the negative 4. Then we have negative 4 plus 2 plus 6. 2 plus 6 is 8. So 4 equals negative 4 plus 8 is positive 4. So these statements equal to each other, which means our solution is correct. So we would just write down the solution set is inside of our curly brackets, inside of our braces, negative 4. Seven, solve and check the following linear equation. 15 equals 4 times x minus 2 in parentheses minus x minus 5 in parentheses. Alright, step 1, we're just trying to solve for x here. Trying to solve for x. So 15, can't do anything with that, equals 4x minus 2. We can go ahead and distribute. 4 times x is 4x. 4 times negative 2 is negative 8. And then we can distribute the negative to both terms in the parentheses. So negative times x is minus x. Negative times negative 5 is positive 5. Keep simplifying. 15 equals, let's actually group the like terms together. So 4x minus x, negative 8 plus 5. Go ahead and simplify that right part of the equation. So 4x minus x is 3x. And then negative 8 plus 5 is negative 3. And we're still trying to solve for x, so we want to get x by itself. So we can add 3 to get rid of that 3. Add 3 to the left side as well. 15 plus 3 is 18 equals 3x. Trying to get x by itself. Let's divide 3x by 3. Then, since I do it on the right side, I have to divide 18 by 3 on the left side. 3 goes into itself once. 3 goes into 18 6 times. So 6 equals x. X equals 6. Then for step 2, we want to put the answer in set builder notation. So we need to use our curly brackets again, 6. There we go. And for the last step, we have to check the solution. So we need to plug in the 6 value into the original equation. So let's do that right now. 15 equals 4. X is going to be 6 minus 2. We're plugging in the two x values of 6. So 6 minus 2 minus 6 minus 5. 15 equals, let's deal inside the parentheses first. So 6 minus 2 is 4. Minus, again, deal with the parentheses first. 6 minus 5 is 1. 15 equals 4 times 4 is 16. Minus 1. 15 equals 16 minus 1 is 15. 15 does equal 15, which makes this statement true, which means that our answer of 6 is correct, and we would just go ahead and write the solution set is positive 6 inside of our braces or curly brackets. 8. Solve and check the following linear equation. 58 minus all inside of brackets 5 plus 6y minus 2y plus 2 in parentheses equals negative 3 times 2y minus 6 in parentheses minus bracket 9 times y minus 1 in parentheses minus 6y plus 10. So step 1, we just want to solve for x using PEMDAS. But actually x isn't right. In this equation, y is the variable, so we want to go ahead and solve for y. Alright, so we want to use PEMDAS, which is our order of operations, which tells us first we use parentheses, exponents, multiplication, division, then finally addition and subtraction. So using PEMDAS, 58 minus, we want to start with what we have here in parentheses. So 5 plus 6y, negative 2 times y is minus 2y, negative 2 times 2 is negative 4, close the brackets, equals, we can distribute this right here, the negative 3, we can distribute that, so negative 3 times 2y is negative 6y, negative 3 times negative 6 is positive 18, and now we can move to inside of the brackets. We can start by distributing the 9 with y minus 1. So we have minus bracket 9 times y is 9y. 9 times negative 1 is negative 9. And then minus 6y plus 10. Close the brackets. Yeah, that's a plus. Want to make it clear. Okay, keep simplifying. So 58, working inside the brackets now. Let's go ahead and group the like terms together. So we have 5 minus 4, and then plus 6y minus 2y, close the bracket, equals negative 6y plus 18 minus, again, let's group the like terms. Let's group the y's with the variables. So 9y minus 6y, and then let's group together negative 9 and positive 10. So minus 9 plus 10. Keep simplifying. 58 minus 5 minus 4 is 1. 6y minus 2y is just 4y plus 4y. Close the bracket. Minus 6y plus 18 minus, okay, 9y minus 6y is 3y. Negative 9 plus 10 is just positive 1. Okay, now here's an important step. Right here with these brackets, you have to distribute the negative sign to both terms inside the bracket. It's easy to mess this up, so we want to distribute just the negative sign. So minus times 1 is just minus 1. The minus times 4y is just minus 4y equals negative 6y plus 18. And over here we have to do the same thing. We have to distribute the negative inside the bracket, so negative times 3y and negative times a positive 1. So negative times 3y is just minus 3y. Negative times a 1 is just minus 1. Okay, keep simplifying. 58 minus 1 is 57 minus 4y equals, alright, let's group together the like terms so we don't get confused. Negative 6y minus 3y plus 18 minus 1. So 57 minus 4y equals negative 6y minus negative 3y is negative 9y. And then 18 minus 1 is just positive 17. And again, we're solving for y, so we want to try to get y by itself. So let's add 9y from the right side, and then add, and since we added 9y to the right side, we have to add it as well to the left side. So 57 negative 4y plus positive 9y is just positive 5y equals, we have 17. Now we want to get the y by itself, so let's subtract 57 from both sides. We end up with 5y equals negative 57, or 17 minus 57 is negative 40. And then trying to get y by itself, let's divide 5y by 5 on the left side, also do it on the right side, and that gives us y equals negative 40 over 50. 5 goes into itself once, 5 goes into negative 40 8 times, so y equals negative 8. And going to step 2, we want to put the answer in set builder notation. So bust out the curly brackets, negative 8 in the parentheses, and the final step is to check our answer. So we want to take this negative 8 value and we want to plug it into our original equation. So let's look at our original equation up top and plug in everywhere we see a y value. We have to go ahead and plug in our answer down here, which was negative 8. So let's try to write this as neatly as possible. So we have 58 minus 5 plus 6, negative 8, minus 2, negative 8, plus 2 equals negative 3, 2, negative 8 in parentheses, minus 6, I'm running out of space, but minus 9, negative 8, minus 1, minus 6, negative 8, we're running out of space, negative 8, and we'll just put plus 10, bracket on the bottom. Alright, so the first thing we want to do to simplify this is really each of these equations, each side of the equation is separate. So this left side of the equation has to be equal to the right side of the equation for negative 8 to be the right answer. So let's just focus on the left side to begin with. So 58, okay, we got 58 minus 5, 6 times negative 8, so 5 is just negative 48. This times this is negative 48, so minus 48, minus 2, parenthesis, negative 8 plus 2 is negative 6. Keep the bracket, equals. Again, we'll stick with the left side of the equation to begin with, so 58 minus, let's do our parentheses first because that's order of operations. 5 minus 48 minus negative 2 times negative 6 is a positive 12. So positive 12 here in the bracket. Then we can simplify inside the bracket. So 5 minus 48 is negative 43. Negative 43 plus 12. So 58 minus negative 43 plus 12 is negative 31. Yeah, negative 31. And then this step is important. You have to remember to distribute what's inside the, you have to distribute this negative side to what's inside the bracket. So negative times a negative 31 gives us positive 31, and if you add 58 plus 31, you end up with 89. So 89 is our answer for the left side of the equation. And actually, let's try to give ourselves a little more room here. So with the left side of the equation, we have, let me see, negative 3 times, all right, 2 and negative 8 we can multiply, so that gives us negative 16, and then minus 6, we have minus, and we have all this bracket, so we have to focus inside the parenthesis. We can subtract that, so minus 9 times negative 8 minus 1 is negative 9, and then negative 6 times negative 8 is positive 48, and then plus 10, close the brackets, keep simplifying here. We can deal with inside the parentheses first, so negative 3, then we have negative 16 minus 6, that's going to give us negative 22, and then minus, alright, so inside the brackets we have 9 times a negative 9, which is negative 81, plus 48 plus 10, 48 plus 10 is 58. Okay, so negative 3 can multiply with negative 22, which gives us a positive 66, minus, we have negative 81 plus 58, and that gives us, that gives us 30, let me think, 81 minus 58, 7, 1, 3, 2, so minus 23. Okay, so we have, yeah, so we have negative 23 in the brackets, and then we have to remember to distribute this negative sign. So 66 plus 23, 66 plus 23 is 89. And as you can see, both of these answers are the same, so we know that our negative 8 answer is true, and we just have to write down the solution set is, inside our curly brackets, negative 8. Solve. 4x over 5 minus x equals x over 10 minus 9 over 2. Alright, first step, we need to find the LCD of all terms. That's the lowest common denominator. We need to multiply each term to have a denominator of 10. So if we look right here, 5, 10, and 2, well, 10 is the highest number, and it goes into itself. 5 goes into 10, and 2 also is a multiple of 10. So we can just go ahead and multiply all the terms in such a way that all 4 terms of this equation will have a denominator of 10. So to get 5 to be a denominator of 10, we have to multiply 2 times 5. We have to multiply the numerator and the denominator. And then to get x, which is really the same as x over 1 to be 10, you have to multiply the denominator and the numerator by 10. X over 10, it's already 10, which is the LCD. And then 2, just like over here, we need to multiply, we need to multiply 2 by 5 to get a denominator of 10, and then also the numerator. So when we multiply this out, we'll start by multiplying the numerators. So 2 times 4x is 8x. 2 times 5 is 10, minus x times 10 is 10x. 1 times 10 is 10, equals x over 10 minus 9 times 5 is 45, and then 2 times 5 is 10. And if we look at step 2, it says since the denominators are the same for all terms, then we can get rid of the denominator 10. So in this equation, all 4 of these denominators are now the same. So we can get rid of them. Now we're left with just the numerators, which is 8x minus 10x equals x minus 45. And then if we simplify, we have 8x minus 10x, which is negative 2x, equals x minus 45. And if we subtract, we want to get x on one side, so x by itself. So if we subtract x from both sides, we have negative 3x equals negative 45. And if we divide by negative 3 on both sides, x 3 goes into itself 1, 3 goes into 45 15 times. So x, because it's a negative divided by a negative, x equals positive 15. And actually over here we kind of did step 3 because we ended up solving for x here, and then you have to put the x answer in curly brackets. Now the last step is we want to check. We want to make sure that this positive 15 is indeed the right answer. So take our original equation, 4 over 5. We want to plug in the 15 minus, we have an x right here. So we want to plug in that 15 equals, plug in this 15, 15 over 10 minus 9 over 2. So we can multiply the numerator, these two values. So 4 times 15 is 60 over 5 minus 15 equals 15 over 10 minus 9 halves. 60 or 5 goes into itself once, 5 goes into 60 12 times. 12 over 1 is the same as 12 minus 15 equals 15 over 10 minus 9 over 2. 12 minus 15 is just negative 3. And then right here we want to find the LCD of 10 and 2. 10 is the highest, 2 goes into 10 5 times, so we want to multiply the numerator and the denominator by 5. That way we get the same denominator and we can actually subtract these fractions. So you'd have 15 over 10 minus 45 over 10, and if you subtract 15 minus 45, you have negative 3 equals negative 30 over 10, and negative 30 over 10. 10 goes into itself once, 10 goes into 30 3 times, and you end up with negative 3. So in this case, negative 3 equals negative 3. So we know our answer of 15 is right because you got negative 3 on the left side, and then you end up right here with negative 3 on the right side. So the solution set is 15 in braces and curly brackets, and that's that. 10. Solve the equation. X plus 1 over 5 equals 1 minus x plus 3 over 3. First step, we want to find the LCD of all terms, and we should multiply to make each term have a denominator of 15. So in this equation, we're solving for x. But we have a fraction on this side and 2 terms on the right side. We want to get the lowest common denominator of all of these terms. So what we can do is lowest common denominator of 5 and 3, and this would be like a 1, would be 15. So what times 5 equals 15? 5 times 3, multiply the top and the bottom, and then this would be 15, 1 times 15, x plus 3 over 3, so 3 times 5 is 15, multiply the top as well. So we end up having 3x plus 1 equals 15 times 1 minus x plus 3 times 5, and our numerator is 3 times 5 is 15, 15 times 1 is 15, 3 times 5 is 15, so we have the same denominator, and then we can just distribute the numerators. So 3x plus 3 times x is 3x, 3 times 1 is 3 over 15 equals 15 times 1 is just 15 over 15, and then we can distribute this 5 times 3 and then 5 times x, so minus 5x, 5 times x, 5x, 3 times 5 plus 15 over 15, and then step 3, actually it turns out I didn't use the right color for step 2. Well, actually no, step 2. Now that I've gotten all the denominators the same, we can simply get rid of them. That leaves us with 3x plus 3 equals 15 minus 5x plus 15. And then moving to step 3, we can solve for x. So we need to solve for x here. So to solve for x, 3x plus 3, can't do anything with that. And actually I made a mistake here. So right here up top, I should be distributing the negative sign to both of these. So it should be negative 5x and it should be minus 15. So 15 minus 5x minus 15. And then you end up with 15 minus 15 is actually nothing, so that gets rid of both of these, and you have a negative 5x. And then if you add 5x to both sides, you have 8x plus 3, and then if you equals 0, you subtract 3 from both sides, you end up with 8x equals negative 3, trying to get x by itself, divide 8 by both sides, and x equals negative 3/8. And you have to put this answer in set notation, or set builder notation in the curly brackets. And the final step is to check. So we need to plug in our negative 3/8 into both sides of the original equation. So let's kind of cut this in half, start with each side. Our original equation is x plus, well actually so x plus 1 over 5 equals 1 minus x plus 3 over 3. And let's plug in the x value. So x value is negative 3/8 plus 1 over 5 equals 1 minus minus negative 3/8 plus 3 over 3. We can start with the left side of the equation, and we can just go ahead and simplify this. So negative 3/8 plus 1. This right here is a complex fraction. And to simplify a complex fraction, we need to get a single term in the numerator and a single term in the denominator. So, and then once we do that, we have to multiply the numerator by the reciprocal of the denominator. So negative 3/8 plus 1, we need to get this to be one term. So to add these two, we need to have the same, we need the LCD. So negative 3/8 plus 8 over 8 divided by 5. Negative 3/8 plus 8 is just 5 over 8 over 5. And just like we said in this step, now we have a single term in the numerator right here, 5/8, and now we have a single term also in the denominator, which is just 5. So we have 5/8 times the reciprocal of 5, which is 1 over 5, which equals 5 over 40. And if you reduce that, 5 goes into itself once, 5 goes into 48 times. So you end up with 1/8. So 1/8 is our answer on the left side of the equation. So now we got to do the right side of the equation, and that's going to be 1 minus negative 3/8 plus 3 over 3. So 1 minus negative 3/8. 3, we need an LCD as well, because we're trying to add two fractions that don't have the same denominator. So LCD would be 8. So multiply the top and bottom by 8. We get 1 minus negative 3/8 plus 24 over 8. And then if you add the two together, 1 minus, and that's over 3. You get negative 3/8 plus 24/8 is negative 21 over 8, and that's divided by 3. And yeah, this is getting a little messy, but negative 21 over 8, just like right here, now there's a single term in the numerator, and with the denominator this is a single term. So now we multiply the numerator by the reciprocal of the denominator, so it'd be negative 21 over 8 times 1 over 3, and that's just negative 21 over 24. And then, I mean, we could simplify that. That's just 7. 3 goes into 21 7 times. 3 goes into 24 8 times, so we have negative 7/8. And then right here we have 1 minus negative 7/8. So we need to have an LCD, so 8 would be the LCD for both. So you'd have 8 over 8 actually I made a mistake. This should be this should be positive 21. Should be positive 7/8, just because negative 3 plus negative 3/8 plus 24/8 is actually positive 21/8. So if we have a positive 7/8 here, 1 minus a positive 7/8 is 8/8 minus 7/8, which just equals 1/8. So this is our right side of the equation, and then this right here was our left side of the equation, and again right side. And since both sides were the same, then our answer right here, negative 3/8, is true, and we would just write the solution set is negative 3/8 inside of the set builder notation. Complete part A and B for the following equation. 8/9x plus 27 equals 2/x plus 3 minus 2/9. A. Write the value or values of the variable that make a denominator 0. These are the restrictions on the variable. B. Keeping the restrictions in mind, solve the equation. To start, step 1, find the x value or values that make the denominator equal to 0. So we're trying to take care of this A step, which is to find the restrictions on the variable. So to do this, we need to set the denominators equal to 0 and solve for x. So our denominators for this equation are 9x plus 27 and x plus 3. These are the denominators with the variable x. So if we set 9x plus 27 equal to 0 and x plus 3 equal to 0 and solve for x, then we get our restrictions. So 9x plus 27, to get x by itself, subtract 27 from both sides. You have 9x equals negative 27. To get x by itself, divide 9x by 9. Divide it on the other side. X equals 9 goes in itself once, into negative 27 3 times. X equals negative 3. Here, x plus 3 equals 0. It's pretty simple. To get x by itself, subtract 3 from the left side, and then subtract 3 from the right side. So x equals negative 3. So for this equation, we know that our restrictions on the variable x are x cannot be negative 3. Because if x is negative 3 in either of these situations, then the denominator would be 0. And the denominator can't be 0, so that's part A. The next part, part B, it says, which is step 2, it says keeping the restrictions in mind, solve the equation. So for step 2, we want to find the LCD to solve the equation. Here it says the LCD is 9x plus 27. So what is our original equation? We have 8/9x plus 27 equals 2/x plus 3 minus 2/9. So the LCD for these 3 terms is 9x plus 27. So we have 9x plus 27, and to to get 9x plus 27 here, you have to multiply the top and the bottom by 9. And then here, you have to multiply the top and the bottom by x plus 3. So we know 9 times 3 is 27. X times 9 is 9x. So we have 9x plus 27. And we have 2 times 9, which is 18. Then we have 9 times x, 9x. 9 times 3, 27. So 9x plus 27. And then it's minus 2 times x is 2x. 2 times 3 is 6. So minus 2x minus 2x plus 6. And since our denominator is the same, we can get rid of that for this equation. And that leaves us with 8 equals 18 minus 2x plus 6. And we can go to step 3, which is to solve for x. To solve for x for this, we have 8 equals, we have 18 plus 6, those are like terms, so 18 plus 6 is 24 minus 2x. And then we can add 2x to the left side to get x on the left side. So we have 2x plus 8 equals 24. To get x by itself, subtract 8 from both sides. So we have 2x equals 24 minus 8 is 16. And actually, a quick correction, I made a mistake over here. Let's just kind of start over. I had right here, when I multiplied, this negative sign should have distributed to both of these. So it should have been 8 equals 18 and then minus 2x, and negative 2x, negative 2 times positive 3 should have been negative 6. And then right here I can simplify. So 8 equals 18 minus 16 is 12 minus 2x. Add 2x to both sides. I have 2x plus 8 equals 12. If I subtract 8 from both sides, it's 2x equals 4. To get x by itself, subtract 2 from both sides. And then you have 4 over 2. X equals 4 over 2. 2 goes in itself once. 2 goes into 4 twice. So x equals 2. And we want to put that in the brackets. And for step 4, we want to compare your solution set with your restrictions. This right here is our solution set. Actually, it shouldn't be x. It should be 2 in the brackets. So this is our solution set right here, the 2. If we compare that all the way over here with negative 3, then we see they're not the same, so we're okay. And the last step we need to do is we need to check our answer by plugging the x value into the equation. So we're gonna go ahead and check our answer by plugging in the values, the x value of 2, a positive 2, into our initial equation. So 8 over 9 times 2 plus 27 equals 2 over 2 plus 3 minus 2 over 9. So you have 8, And then 9 times 2 is 18 plus 27 equals 2 over 2 plus 3 is 5 minus 2 over 9. And then 8 over 18 plus 27 is 45 equals, we have 2/5 and minus 2/9, but we can't subtract these two fractions because their denominators are different. So we need to find an LCD, our lowest common denominator, and the LCD of 5 and 9 would be 45. So to get that, you can multiply this side by 9, multiply this side by 5, and you have 8 over 45 equals 9 times 2 is 18 over 45, because 9 times 5, and then minus 2 times 5, which is 10. 9 times 5 is 45, and 8 over 45 equals 18 over 45 minus 10 over 45. 8 minus 10 is just 8 over 45, and since the equation matches, since this is a true statement, then we know that the solution set is positive 2. And that's how you check. 12. Find all values of x such that y equals 0. Y equals x plus 6 over 5x minus 10 minus 6 over x minus 2 minus 2 over 5. So step 1, we need to find the LCD, and the LCD is going to be 5x minus 10. So we're solving for x here, and we need to start, because we have all these three terms are fractions, we need to find the LCD for all three terms. So let's just write this again. Y equals x plus 6 over 5x minus 10 minus 6 over x minus 2 minus 2 over 5. So the LCD is going to be 5x minus 10. So we can keep this term the same. X minus 2, to get x minus 2 to be 5x minus 10, we have to multiply the denominator by 5, which means we multiply the numerator by 5 as well. And then to get 5 to be 5x minus 10, we have to multiply the denominator by x minus 2 and do the same for the numerator. And now we just have to distribute these terms. So y equals x plus 6 over 5x minus 10, and then you have 6 times 5, so minus 30, and then x times 5 times x is 5x, 5 times negative 2 is negative 10, so 5x minus 10. And then here we have to be careful. We're not multiplying just 2 by x, 2 by negative 2. It's negative 2x by x, which is negative 2x, and then negative 2 times negative 2 gives us a positive 4. And that's over 5 times x, 5x, 5 times negative 2, which is negative 10, 5x minus 10. Now step 2, once the denominators are the same, then you can get rid of them. So here we have three terms that have the same denominator, 5x minus 10, so we can simply get rid of them. And once we get rid of them, we're left with y equals x plus 6 minus 30 minus 2x plus 4. And then for step 3, we can just go ahead and solve for x. So to solve for x, we want to get together like terms. So we have, let me see, y equals x 6 minus 30, or 6 positive 6 minus 30 is negative 24 minus 2x plus 4. Again, let's group together the like terms. So we have y equals x minus 2x minus 24 plus 4. And that gives us y equals x minus 2x is just negative x. And then negative 24 plus 4 is just negative 20. And then if we have negative x, we want to get x by itself. We just add x to both sides. And we end up with x equals negative 20, which we put in the curly brackets. So we have negative 20. And that's actually what I did right here. I put the solution in set builder notation. That's what this is right here. So the last thing we need to do is we need to check the answer by plugging in our x value, and once we put the x value into the equation, the x value, which is negative 20, which is what we have here, should make our equation equal to 0. So let's plug it in. We have 0, which is our what our y is supposed to be, because right here it says such that y equals 0. We have 0 equals, our x value is negative 20, so negative 20 plus 6, 5 times negative 20 minus 10 minus 6 over negative 20 minus 2 minus 2 over 5. So let's simplify. 0 equals negative 20 plus 6 is just negative 14. And then 5 times negative 20 is negative 100 minus 10. And we got minus 6. And then minus 20 minus 2 is minus 22. Minus 2 over 5. 0 equals negative 14. Negative 100 minus 10 is negative 110. Minus 6 over minus 22 minus 2 over 5. And then right here, 14 over 110, well, both of these are negative signs, so a negative by a negative gives us a positive, so it's just positive 14 over 110 minus 6 over negative 22 minus 2 over 5. And here we need to subtract these three fractions. We need to find an LCD, and LCD I can see right here is going to be positive 110 and actually right here we have negative 6 minus 6 over 22, so we can, two negatives gives us a positive. So we have 14 plus 6 over 22 minus 2 over 5. So 0 equals 14 over 110 plus 6 over 22 minus 2 over 5. And 22 goes into 110 5 times. So multiply both numerator and denominator by 5. And then 5 times 22 is 110. So to get 110 as our LCD, just multiply the denominator and numerator by 22. So we end up with 0 equals 14 over 110 plus 30 over 110 minus 2 times negative 2 times 22 is negative 44 over 110, and 0 equals 14 over 110 plus 30 over 110 is just 130, or is just 34 over 110, 34 over 110, and then minus 44 over 110, you have 34, actually hold on, getting my head of myself here. So 14 plus 30 is 44 over 110. Then minus 44 over 110. 0 equals 0, because this minus this is 0. So because 0 equals 0, which is what our y was supposed to be, then we know that our negative 20 answer is correct. So we would just write the solution set is negative 20. And we know that's true because we just checked it. Solve the following formula for the specified variable. B equals 1 over 3 f times n for f. So step 1, we want to get rid of the fraction by multiplying both sides by 3. For this equation, we're solving for f. So b equals 1 over 3 fn. We want to get rid of this fraction, so we can multiply both sides by 3. We end up with 3b equals, really 1/3 times 3 is the same as 3 over 3 fn, and 3 over 3 is the same as 1. 3b equals 1 fn. The 1 is redundant, so we can just have 3b equals fn. And then step 2, we just need to solve for f. So to get f by itself, we just divide both sides by n. We end up with 3b n equals f, or f equals 3 capital B over n. Solve the following formula for the specified variable. Capital A equals capital Y HD, and for capital Y. So step 1, solve for y by dividing HD on both sides of the equation. This isolates the variable y and solves the equation. So pretty easy, one step. We have capital A equals capital Y HD. We're solving for this variable y. To get y by itself, we can just go ahead and divide by HD. Do that on one side, we have to do it on the left side as well. And you end up with capital A over HD equals capital Y. And you can just write that as capital Y equals A over HD. Solve the formula for the specified variable. K equals UD squared for U. 1, solve for U. So really easy. Step 1, solve for this U variable. So K equals UD to the second power. To solve for U, we can simply divide d squared by both sides, which gets u by itself. So you have k over d squared equals u, or u equals k over d squared. Solve the formula for z. G equals b over z minus w. So step 1, we want to cross multiply. Cross multiplication is when you have a over b equals c over d, and you multiply a by d just from top to bottom across the equal sign, and then b gets multiplied by c, so from bottom to top. So essentially AD equals BC. Alright, so G equals B over Z minus W. Let's write that again. And honestly, I have trouble identifying when to cross multiply, but I guess it's when you have, like, g is basically g over 1, which is a fraction, equals b over z minus w. So when you have a fraction equal to a fraction and you're solving for a variable, I think that's one of the cues that you might need to cross multiply. So if we do that, we have to multiply g by z minus w and b times 1. B times 1 is just b equals g times z minus w. We have to go ahead and distribute g times z and g minus w, so we have b equals g times z is gz, g times negative w is just minus gw. Now for step 2, we need to add gw to both sides, so plus gw plus gw, b plus gw equals gz. Now step 3, want to divide g by both sides to get z by itself. Again, we're solving for z, so we want to get z by itself. So divide g by both sides of the equation, and we end up with b plus gw over g equals z. So let's write that again up here. We have z equals b plus gw over g. Now for step 4, we want to split the numerator terms b plus gw into two separate fractions with the same denominator g. So pretty much right here, we want to try to further simplify this, but everything's clumped together, so we can't, because both of these terms in the numerator aren't multiples of the denominator. So we want to split up the fraction. Z equals b over g plus g over w over g. And then for step 5, we want to go ahead and simplify gw into w, since g over g canceled out. So b over g can't simplify that, but g goes into itself once, g goes into g once, and you end up with z equals b over g plus w. Solve capital A equals 2 capital B capital C plus 2 capital B capital D for capital B. So step 1, just use the reverse distributive property. I think that's what it is called. Or pretty much just factor out the two terms on the right side of the equation. This factors the two right terms to 2b cd. So let's rewrite the problem. A equals 2 capital B capital C plus 2 capital B capital D. Alright, now we want to factor out these two terms on the right side, capital 2bc and plus capital 2bd. Now both of these terms have a 2b in them, so we can factor that out. So you have a equals 2b times, in parentheses, c capital C plus capital D, and next you can go ahead and divide both sides of the equation by 2c plus d in parentheses, which will get capital B by itself. So right here we just want to get b by itself, so we can divide everything but b. So 2 capital C plus capital D in parentheses. We divided that on the right side, so we have to divide 2 capital C plus capital D in parentheses on the left side as well. And we just end up with capital A over 2 capital C plus capital D equals B. Or we can just write that as B equals capital A over 2 times capital C, that's parentheses, 2 times capital C plus capital D. Solve the formula for C. 1 over D plus 1 over N equals 1 over C. Step 1. Find the LCD. So just rewrite our equation. 1 over D plus 1 over N equals 1 over C. Now we want to find the lowest common denominator for the 3 fractions. So each term is unique, so each term would need one of the other. So D needs Cn multiplied by the numerator as well. N needs C and D multiplied by the numerator and denominator. And then C would need N and D multiplied by the numerator and the denominator. So we end up with 1 times Cn is just itself, CD times 1 is just CD, ND times 1 is just ND. So Cn, and the bottom, your numerator would be, or your denominator would be just the 3 terms. Let's put them alphabetically. So you'd have CDN plus CD over CDN equals ND times 1 is just ND, again over CDN. Step 2 says to get rid of the same denominator. Because we found the LCD, CDN, CDN, CDN are all the same. So we can get rid of that, and that leaves us with Cn plus CD equals ND. And then step 3, use the distributive property to factor the 2 terms on the left side of the equation, and this will become C times N plus D in parentheses. So we want to factor out these two because both of these terms, Cn and CD, both have a C, so we can factor that out. So it's C times N plus D equals, close the parenthesis, equals ND. And then step 4, we want to go ahead and divide both sides by N plus D in parentheses to get C by itself. Again, we're solving for C. So divide this side by N plus D in parentheses, and then we did it on the left side, so we have to divide N plus D on the right side as well. And we end up, because these will cancel each other out, we end up with C equals ND over N plus D. Solve the equation. In brackets you have 3 plus 12 in parentheses to the 2nd power divided by 3, bracket closes, times 2 equals 75x. First step, PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. So we just want to go ahead and do order of operations. So let's first do 3 plus 12 in the parentheses, which is 15, squared divided by 3 inside the bracket times 2 equals 75x. Again, we're solving for x in this equation. So 15 squared is 225 divided by 3 close the bracket, times 2 equals 75x. Inside the bracket, 225 divided by 3 is just 75 times 2. Bracket looks a little crazy. Times 2 equals 75x. We can just get rid of the bracket. So we have 75 times 2 equals 75x. And 75 times 2 is 150 equals 75x. We'll want to solve for x, get x by itself, divide 75x by 75, 150 by 75. That gives us 150 over 75 equals x, and we can simplify that. 75 goes into itself once, 75 goes into 150 twice, so we end up with 2 equals x, or x equals 2. Now, and we can put that into our curly brackets. Now we want to go ahead and go to step 2, which is just to check the answer by plugging in the x value. So we can just run through this quick because we already kind of did all of these steps, but we can just do them again just to be thorough. Now right here we're plugging in the x value of 2, but on the left side there's no x value, and as we saw here, we evaluated the left side of the equation and we ended up getting 150. That was for the left side of the equation, because 3 plus 12 is 15, squared is 225, and actually this should be divided by 3. 225 divided by 3 was 75 times 2 is just 150. And that's the same thing we did during these steps right here. So 150 equals 75 times 2, which is 150. And 150 equals 150, so this is a true statement. It's a true statement, and thus 2 right here is our answer. 20. Solve the equation. 9 minus 7x equals 5 minus 3x minus, in parentheses, 6 divided by 3 times 3 plus 4 squared, in parentheses, plus 4x, close the parentheses. So step 1, just order of operations, we're just going to try to solve for x here. So 9 minus 7x equals 5 minus 3x minus 6 divided by 3 is 2. 3 plus 4 squared, it's an exponent, so take care of that. 4 squared is 16 plus 4x, close the parenthesis. So 9 minus 7x equals 5 minus 3x minus 2, 3 plus 16, which is the parenthesis within the parenthesis, is just 19 plus 4x, close the parenthesis. 9 minus 7x equals 5 minus 3x minus 2 times 19 is 38 plus 4x, close the parenthesis. 9 minus 7x equals 5 minus 3x. Need to make sure to distribute this negative sign to both terms in the parenthesis. So negative times 38 is negative 38. Negative times positive 4x is negative 4x. Keep simplifying. 9 minus 7x equals Now let's just go ahead and group the like terms together. So 5 minus 38 minus 3x minus 4x. So 9 minus 7x equals 5 minus 38 is negative 33. Negative 3x minus 4x is negative 7x. And if we want to get x by itself, so let's add 33 to both sides. We end up with 42, or 9 plus 33 is 42 minus 7x equals negative 7x. Want to get x by itself, so if we add 7x to both sides, we end up with 42 equals 0. And 42 equals 0 is not a true statement. This right here is not a true statement. And because of that, so the solution set is the null set. No solution. 21. Solve the following formula for the specified variable. B equals pi h squared t for t. Step 1. Solve for t. Just trying to solve for t. Let's rewrite the original problem. B equals pi h squared t. To get t by itself, we just want to divide pi h squared on both sides. Pi h squared. So these cancel out. So b over pi h squared equals t, or t equals capital B over pi h squared. Solve the formula for Q. Capital S equals capital D plus QF. Step 1, solve for Q. That's it. We're trying to get Q right here by itself. So we can just go ahead and subtract D from both sides. Capital S minus capital D equals QF. To get Q by itself, just divide QF by F. Divide the left side by F as well. So S, capital S minus capital D over F equals Q, which is the same as Q equals capital S minus capital D all over F. 23. Solve the following formula for the specified variable. B equals a half m times r plus k in parentheses for r. Step 1. Multiply the variable m by 2 and the left side of the equation by 2 in order to get rid of the half fraction. So you want to get rid of the fraction. It says do not multiply r plus k in the parentheses by 2. So let's take a look at that. Start by rewriting the equation. B equals 1/2 m r plus k. Now we want to get rid of the fraction, so we don't need to multiply this part. We just need to go ahead and multiply the fraction itself by 2 over 2. Or not even 2 over 2, just by 2, which is the same as 2 over 1, which would just be 2 over 2, which is 1, which would get rid of that fraction. And we multiply it on the right side, so we have to multiply 2 on the left side as well. So that gives you 2b equals m and r plus k times r plus k in parentheses. Now for step 2, we need to go ahead and divide m on both sides of the equation. So we're trying to get r by itself, so divide both sides by m. So we have 2b over m equals r plus k. And now that there's nothing multiplying on the left of the parentheses, we can just lift up the parentheses. We can just get rid of them. So 2b over m equals r plus k. And step 3 says we need to go ahead and subtract k on both sides of the equation to get r by itself. So if we subtract k on both sides of the equation, we end up with 2b over m equals 2 capital B over capital M minus k equals r, which is the same as r equals 2 capital B over capital M minus k. 24. Solve the following formula for t. Capital A equals capital Q plus capital Q RT. Step 1. Subtract Q from both sides. We want to solve for t, so let's subtract Q from both sides. Capital A minus Q equals Q RT. Step 2. Divide both sides of the equation by capital QR to get the variable t by itself. We want to get t by itself. Divide the right side by capital QR. Divide the left side by capital QR. We end up with capital A minus capital Q over capital QR equals t, which is also the same thing as t equals capital A minus capital Q over capital QR.